CBT, ionic bond, covalent bond, VBT, hybridization, valence shell electron pair repulsion theory, MOT, and bond parameters. Chemical bond theory proposed by Covalent Lewis. Valence electrons involves in a chemical reaction to attain 8 electrons. Attaining of 8 electrons in a valence shell is known as octet rule. Limitations of octet. Expanded octet. Sulfur hexafluoride 12, IF7, 14, incomplete octet, BeCl2 4, BF4, 6 electrons. Odd electron species, around nitrogen, 7 electrons. Lewis dot structure for an atom, around helium, 2 electrons. Formal charge for a neutral molecule, formula, total valence electrons minus total unshared electrons minus half of the total shared electrons. Valence electrons, unshared electrons, shared electrons. Formal charge in radicals. Average formal charge for oxygen in PO4 3- is -3/4. Ionic bond. Bond formed between ions due to transfer of electrons. Example, Na plus Cl-. Favorable conditions. Big cation, small and. Small anion, big and. Here A, electron affinity, N, electronegativity, T, ionization potential. Small charge on cation. For example, Na plus more ionic than Mg plus 2. Properties. Hard, high melting and boiling points. Brittle, bad conductors of electricity in solid state and non-directional. Solubility. Like dissolves like. Hydration energy greater than lattice energy, it is soluble. Hydration energy is lesser than lattice energy, insoluble. Lattice energy is directly proportional to the product of charges. Lattice energy inversely proportional to size of the cation and anion, where He hydration energy, Le lattice energy. Bond formed due to mutual sharing of electrons. Example, HCl. Favorable conditions. Big anion, small and. Small cation, big and. More charge on cation. Example, Al plus 3 more covalent than Mg plus 2, Cu plus 1 covalent. Properties. Soft, low melting and boiling points except diamond, graphite. Non-brittle, bad conductors for electricity. Good conductors in aqueous state and directional. Solubility. Soluble in non-polar like benzene, carbon tetrachloride. Insoluble in polar like water. Alcohol and amines soluble in water due to formation of hydrogen bond. Dipole moment, measurement of polarity in a covalent bond. Polar molecule due to dissimilar atoms. Example, HCl, H2O. Non-polar molecule due to similar atoms and symmetrical structure of molecules. Example, similar atoms Cl2, N2, H2. Symmetrical structure BeCl2, boron trifluoride, CH4. Electronegativity increases, polarity also increases. Calculations. For AB molecule, mu is equal to C into D, where C charge, D distance. For ABC molecule, mu is equal to root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Dipole moment is maximum if theta is equal to 0. Dipole moment is minimum if theta is equal to 180 degrees. for ABT molecule. Mu is equal to 2 into bond moment into cos theta by 2. Percentage of ionic character is equal to mu observed by mu calculated into 100. Note, 1 dBi is equal to 3.33 into 10 power minus 30 coulomb meters. Valence bond theory. Valence electrons involved in a bond with the opposite spin. Sigma bond due to axial overlapping. Pi bond due to lateral overlapping. Strength of the bond. PP is greater than PS greater than SS for same n values. 1s 1s greater than 1s 2s greater than 2s 2s for different n value. N value increases, bond strength decreases. For all molecules, bond angle is 90 as per VBT. Hybridization. Intermixing of atomic orbitals. Hybridization does not depend upon number of electrons. Hybridized orbitals belongs to same atom. Before hybridization, orbitals are known as pure atomic orbitals. Hybridized orbitals are stronger than pure atomic orbitals. Number of hybridized orbitals are equal to pure atomic orbitals involved. Example, S plus P gives 2sp. Based on number of sigma bonds around central atom. Number of sigma bonds hybridization. If 2 sigma sp, 3 sp2, 4 sp3, 5 sp3d. Based on formula, total pair of electrons is equal to V plus M minus C plus A by 2. If 2, that is sp, where V is equal to valence electrons of central atom, M is equal to number of monovalent atoms, C and A is equal to charge of cation and anion. Based on total valence electrons in a molecule, if total valence electrons are greater than 8, then divided by 8. If total valence electrons are less than or equal to 8, then divided by 2. For example, H2O, total valence electrons are 8. So, less than or equal to 8 divided by 2, 8 by 2 is equal to 4. If quotient is 4, that is sp3 hybridization. Valence shell electron pair repulsion theory. Valence electrons involved in a bond are as lone pairs in a valence shell. Valence electrons repel each other. Order of repulsion, lone pair is greater than lone pair is greater than bond pair. Total pair of electrons is equal to V plus M by 2, where V is equal to valence electrons of central atom, N is equal to number of monovalent atoms. Number of lone pairs is equal to total pair of electrons minus total bond pair of electrons. For example, in BeCl2, total pair of electrons 2, bond pair of electrons 2, lone pair of electrons 0. Molecular orbital theory. All the bonding electrons belongs to molecule only. Due to linear combination, atomic orbitals gives molecular orbitals psi A plus or minus psi B. Bonding molecular orbital due to constructive wave psi A plus psi B. Anti-bonding molecular orbital due to destructive wave psi A minus psi B. Energy levels in molecular orbitals. Z less than or equal to 14, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2 px, pi 2 py, sigma 2 pz, pi star 2 px, pi star 2 py, sigma star 2 pz. Z greater than 14, only difference sigma 2 pz only. Number of electrons in a molecule are radical and bond order. Number of electrons 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Bond order 1, 1.5, 2, 2.5, 3. From there decreases 2.5, 2, 1.5, 1, 0.5, 0 respectively. Bond parameters. Bond length. Equilibrium distance between two nuclei. Hint, 1 by bonds. Inversely proportional to polarity, bond order, negativity, dipole moment, S character. Bond energy. Energy required to break a bond. Hint, bonds. Directly proportional to polarity, bond order, negativity, dipole moment, S character. Bond length. The angle between two bonded atoms in a molecule. Hint, note. Directly proportional to negativity, bond order, and terminal atoms. Inversely proportional to lone pair of electrons.